you hear me? Good evening, everybody. We're going to get started here in just a second. So if people could take their seats, I sure would appreciate it. Everybody. Good evening, everybody. Can you not hear me? Can you hear me? Hi. It is. Hi, if everybody could take their seats, we could get started. We've got a really great lineup tonight, and I want to tell you about a few things before we get going. First of all, we're going to have a little drawing. So when you all came in tonight, I'm sure you got actually a little ticket. So we'll be having a drawing later on in the evening for one of those CAFO books. It's a really nice coffee table size book, but the images are a little disturbing, but there's lots of information in there. We also, we're going to have a great lineup. We have 5 speakers that are going to be talking first about the recent legal information, giving a background and introductory background on the Buffalo River CAFO. And then we'll start in on the science about bacterial loads and some of the work that the National Park Service has done. And then we'll head into antibodies and bacteria, another bacterial load issue. And then Van Brahana will talk about some of the some of the dye tracing work he's been doing. And then we will close out with some of the legislative action that's going to take place in the near future. After we finish with the speakers, we're going to have a question and answer session. So everybody will be, the 5 panelists will be up here, and you'll be able to ask them questions. We'll have a mic set up where you can get in line to actually ask your question. And part of that, we need you to speak into the microphone tonight if you have comments or questions, because we're actually recording this. So that'll be very important so that we get everybody's question and the answer on the record. And then finally, we will close out with a sing-along. People will come up here and sing, and everybody's welcome to participate. You don't have to be an opera singer. You can come up and contribute and participate any way you would like. So that's kind of the lineup for tonight. Okay. Most of you all know exactly where the Buffalo River is, but I wanted to just put this slide up right here. For those of you that may be new to Fayetteville, we are located about right here. The Buffalo is about an hour and a half away from its western edge. In the red is the outline of the Buffalo River watershed. So just a little point of reference here. And then, why do we like it so much? Well, we love to go kayaking and canoeing and hiking. And so a lot of our interest is preserving this hiking and canoeing and kayaking that we love, but it's also the uniqueness of the area. So without any extra information, I'm going to turn it right over to Dane Schumacher. Oh, actually, let me do your bio. Sorry. So Dane Schumacher is a board member and legal chair of the Buffalo River Watershed Alliance. Dane is a full-time farmer whose focused interest is appropriate environmental land and water use with regard to sustainable agriculture in local and regional watersheds. Prior to farming, Dane worked as a defense litigation corporate paralegal for several high-level profile international law firms. Dane was a member of the legal team involved in the Exxon Valdez oil spill. Thank you, Dane. Can you hear?
Test. Can you hear me okay? Oop. Good evening, everyone. It's an honor to be here this evening. And as I look around the room, I imagine that there are many differences represented here. Political ideologies, religious affiliations, occupational differences, professionals, laborers, teachers, students, conservationists, environmentalists. But the one thing that weaves us together tonight, the one thread that unites us all, is the Buffalo River, the crown jewel of Arkansas. The Buffalo River stirs and sparks a lot of emotions within a lot of folks, and for some, it's almost too indescribable for words. Folks just love this river. And so it was no surprise when a 6,500 confined animal feeding operation, CAFO for short, was permitted to operate in the Buffalo River watershed. People were left shaking their heads. People were stunned. People were dismayed. Some were even outraged. Mostly folks were confused. Why in the world would anyone place a swine facility in the Buffalo River watershed? A facility that generates 2 million gallons of waste annually, approximately the size of a town, roughly 25 to 30,000 people, raw liquid waste, placed in open-air pits, then land distributed on fields in and around the Mount Judy community. Many of these fields are on Big Creek, less than 5 miles upstream from the Buffalo River. Why in the world? Many of these fields, again, were on Big Creek. In Karst, extensive underground drainage system. And lastly, why would anyone place a swine facility near one of America's best ideas, the national park. So I'm here this evening to talk about, quickly, the background, red flags, and ongoing developments. So let's talk about how it happened. My team has been diligently and painstakingly doing Freedom of Information Acts. And that affords citizens in Arkansas, it has one of the best Freedom of Information Acts in the country. It's called the Sunshine Law. And many people were left in the dark, and we still are in the dark. And so my team has tried to put together the pieces of a puzzle to kind of shine light on this. And so we don't know exactly why it happened necessarily, but we've got a pretty good, clear picture of how it happened. So ADQ implemented a Reg 5 in 2012. It was sort of to eliminate the duplicating requirements so that the general permit, the Reg 6, wouldn't overlap. Extensive stakeholder input. Farm Bureau, Cargill, Tyson's, U of A, a lot of folks were involved in this. And what they did was, it was going to be primarily less regulated. It was going to afford the same current protections as the Regulation 5, which was the liquid waste permit for the CAFOs at that time. ADQ recommended the state general permit to CNH. This general permit does not distinguish between karst regions and other regions of the state. The loan guarantees that were made to this facility were inadequate. There was an environmental review for the loan guarantees that were attached to the loan, terribly inadequate. Finding of no significant impact was inadequate. Many of the agencies that were responsible to learn about this, these two agencies were required by law to consult with the National Park Service, to consult with the U.S. Fish and Wildlife. It didn't happen. And there was inadequate notification. The state, it was in the state paper, but these agencies legally had to put it in the paper near the vicinity of the CAFO. This was not done. Terribly inadequate. So I'd like to take you a look at the state of the art. This was touted as a state-of-the-art facility. Folks were told, don't worry about it. We've got everything under control. Pond leakage up to 5,000 gallons per acre per day is allowed. This is in karst. Excess phosphorus. Many of the fields that line Big Creek already have above optimal or above optimal phosphorus levels. Largest field 7, largest field that you see there on the screen, is in a floodplain. We cannot get the phosphorus index for this field. We don't know. Very problematic. 8 fields are adjacent to Big Creek. This is in karst. Proximity to school, this state-of-the-art facility in other states, North Carolina, Mississippi, this technology, open-air pits, has been banned. A lot of reasons why, but primarily they can tend to cause health problems in the elderly, children, and the immune suppressed due to the ammonia hydrogen sulfide concerns. And also in March 2013, the Arkansas Department of Health issued a letter stating that they were concerned of E. coli and cryptosporidium. So I'd like to quickly look at the key developments that happened. August 12, 2012, general permit issued. Cargill contract. July 18, 2013, Governor Beebe extended a rainy day fund. By this time, much public opposition, public outrage. Governor Beebe, under extraordinary circumstances, requests from the legislature $250,000 of taxpayers' money to subsidize a private facility and a multi-billion-dollar corporation. August 26, U of A, Cargill, CNH, and Farm Bureau meet to discuss this plan, to go over some of the particulars. By September 4th, Governor Mike Beebe requested $90,000 more, so it puts the total at $340,000. Andrew Sharpley, Professor Sharpley, who is the lead for the Big Creek research team, he's commented in an email that said they were there really to provide sound science on the nutrient fate and transportation on the farm under the approved nutrient management plan. Governor Mike Beebe on September 4th said the studies will be conducted on behalf of the Arkansas Department of Environmental Quality. The memorandum of agreement between ADQ and between ADQ and the U of A, the university agreed to undertake and complete a study of the potential for water quality impacts within the Buffalo River watershed for animal waste produced by the permitted CAFO. So there's a narrow mandate that the U of A has, and that's to monitor water quality. We met with the governor. My Buffalo River Coalition met with the governor on Monday, and we asked him again, this money that the taxpayers are paying, subsidizing, is it to monitor the water? And he said, yes, indeed it is. And he said, and if there's any evidence that's causing any harm to that river, I will take the necessary steps to shut it down. So in April 2014, Cargill comes to town, had several Cargill stakeholder meetings. Cargill admitted it made a mistake to the Buffalo River Coalition and maybe to some other individual stakeholders, but they said they made an error. It shouldn't have been cited here, and they were going to correct the way. Sometime in April, we know, and this is just an aside, that a owner of a company called Plasma Energy Group had a meeting with ADEQ and submitted a video. May 8th, there was a meeting between U of A at CNH to talk about plasma gasification, and I'll get into that in a little bit. Mid-May, there was a Big Creek research team commissioned a peer review panel. And this panel was a panel of experts. And the experts basically said the one-year study that the U of A has been assigned to do, commissioned to do, is too short. It's not enough time. You need at least 5 more years to study this. They also cited some of the same concerns that I mentioned as far as red flags. And they also said you need to be doing dye tracing. The dye tracing wasn't scheduled in the study for either the 2nd or 3rd year. Dr. Van Brahana had the good sense to begin it immediately. On September 14th, Cargill issued a stakeholder letter to many individuals and to the Buffalo River Coalition saying, no, we're going to stay right here. We decided to stay put. We're going to do some mitigative measures, put in a gas flare. We're going to put some pond covers on one pond, and we're going to put the liners on the ponds. In a letter to the stakeholders, Cargill Swine Operations said, new technology is being examined that has the potential to improve how the entire industry manages and disposes of animal waste. So now we're starting to see a picture. Some of the puzzles are being put together that this state-of-the-art facility that was going to take liquid waste and apply it and use agronomically utilization of nutrients is now sort of becoming into talking about animal waste and disposing of the animal waste. As you see here, the key developments that I've already outlined, they don't completely go away. The U of A is still involved. The U of A is looking at separating out solids. They're even now talking about transporting the waste out of the watershed. But suddenly everything just kind of dissipates. Cargill's still a little involved, and now we're faced with plasma arc technology. This is called state-of-the-art now. 2 years later, this is the leading technology. So what we're watching is this facility suddenly morphing, shape-shifting, and becoming something entirely different than what it was permitted to do. And much to the because of all of the folks that have been dismayed and all the other emotions that underline these legitimate concerns, this is risky technology. The plasma process we know, we did a Freedom of Information Act, and we found out there was a series of communications between ADEQ, CNH, Farm Bureau, pork producers, and the company's owner, Plasma Energy Group. Called it a closed-loop system, which means that if they're successful in doing this, creating plasma, another form of matter, ADEQ is out of the loop. ADEQ, Arkansas Department of Environmental Quality, will no longer be the regulatory agency. We don't know who will regulate these folks. They say it's going to be all electric, no combustion or fuel, little oxygen. But however, in the second chamber, in this schematic diagram that we were able to look at, there is carbon dioxide. So we feel like there is some oxidation that might be happening, and there might be some burning. But anyway, they've requested permission to install and test for an exempt status for permit requirements in the treatment of swine waste. The documents say that this was installed in mid-August with October-November installation, and they want a pilot test run by the 1st of December. This is a pilot program. This is untested, unproven technology. This is what Murray Vance, the Plasma Energy Group president, said. We believe the technology offers a solution for ongoing waste problem in the agriculture industry and Arkansas in particular. ADEQ's response to the Plasma Energy Group cannot recommend approval, cannot be independently evaluated, and it actually may combust waste at some point in the process, permitting requirements for incinerators. What did they do? They told them to proceed at your own risk. So it's an incinerator. We think it's an incinerator. We don't know for sure, but this is risky technology. Some myths and facts. There are several plants, a lot of research has been done that has shown that this is just very untested, unfound technology. The myth is that gasification, the pyrolysis, and plasma incinerators are regulated. Not true. Gasification, pyrolysis, and plasma incinerators are operationally proven. Actually, they have a dismal track record. They're plagued by malfunctions, explosions, and shutdowns. So folks, this swine facility that was permitted to operate, to apply waste or to apply manure, farms apply manure. It's part of what farms do. They put nutrients down. This is not a farm. This is a factory raising pigs that are now going to take the waste and try to figure out something to do with this waste disposal. It's gone from agricultural utilization of, agronomically utilization of nutrients to waste disposal. The Buffalo River watershed is not the place for risky and unproven technology, nor should it be a research station for industrialized agriculture. My team and I, Buffalo River Watershed, I found out just this afternoon that we filed a petition with the Arkansas Pollution and Control and Ecology Commission. We asked to speak at their next Friday's meeting. We are challenging ADEQ. We hope that ADEQ or APC&E will tell ADEQ that they cannot allow this technology to move forward. I'm going to move now into the legal update. I am part of a wider, broader coalition that is Arkansas Canoe Club, our team, National Parks Conservation Association, and the Ozark Society. We filed a lawsuit sometime in August, early September, and we're working with Earth Justice, Earthrise, Carney, Bates, and Pilliam. It's a Little Rock firm. We were the plaintiffs, which means we were the complainants. We filed the complaint. We initiated the complaint. And our premise and where we stood and where we stand today is the treasured Buffalo River, its unique geology, clean waters, the wildlife it sustains, and the people who have been drawn to it are at the heart of our attempt in this action to set things straight. The agencies that we filed suit against are the defendants, Farm Service Agency, which is part of the United States Department of Agriculture, and the Small Business Administration. Our contention is they ignored the law when they decided to commit the resources of the federal government to guarantee loans totaling more than $36 million. This was for the construction of the gestation and farrowing barns, and it was also to purchase 23 acres. This is unprecedented that a 6,500 swine concentrated animal feeding operation is in the watershed of the country's first national river. We also contend that Farm Service Agency and the Small Business Administration rubber-stamped the requested loan guarantees without taking a hard look at the environmental impacts, without notifying and engaging the public and consulting as necessary with the other agencies. They violated the National Environmental Policy Act, the Endangered Species Act, and the Buffalo National River Enabling Act. They failed to comply with both procedural and substantive mandates, and that resulted in undemocratic and flawed decisions that enabled and continue, and I want to stress continue, to make possible the presence of a pollution source that threatens air quality, surface water, groundwater, and the iconic Buffalo National River. We asked the court that they would find the environmental assessment and the finding of no significant impact, which was referred to as FONSI, contrary to law, and that the Farm Service Agency and the Small Business Administration failed to comply with the NEPA, ESA, Endangered Species Act, and the Buffalo River Enabling Act. We also asked that the court stop the guarantees issued by defendants. And we also asked that the court send back the matter to the Farm Service Agency and the Small Business Administration and ask them to do it right. That they need to do a proper environmental review. They need to contact the agencies that were not contacted. And we asked that they meet their statutory and regulatory obligations. We had oral arguments. It was a legal challenge. There were no material facts disputed. So there were oral arguments before the judge. These were just legal arguments. and the judge issued a tentative ruling. The briefs, the judge ordered the plaintiffs and the defendants to submit their briefs by November 6th. The judge, because he has not issued a final order, it's best for me not to talk about how he ruled. But you can ask the court, for the court reporter, to get the copy of the court proceedings. So, and I'll answer any questions on the panel that you have. We have Professor Allen is here this evening. He is our chemist who went through the documents that we did a FOIA on. He understands the pyrolysis process, the technology. Emily Jones with National Park Conservation, Marty Olson, and Alice Andrews are part of the coalition here this evening. They have tables set up, and they'll be happy to answer any of your questions. Thank you very much.
Thanks, Dana. Oh, let me take this off of you. Yeah, I've got one of these. Okay. Thank you, Dane. That was great. Our next speaker is Mr. Chuck Bitting. Sorry, can I get my pad down here? Thanks. Chuck is with the National Park Service, and he's been employed there since 1987 as a Natural Resource Program Manager. He holds a bachelor's in geology from Missouri State University. During his tenure at the Park Service, he has worked on a wide variety of projects. Many of these include the documentation and protection of karst landforms and associated natural and cultural resource and features, endangered bat surveys and habitat monitoring using direct counts, electronic data loggers and acoustic bat monitoring, abandoned mine surveys and reclamation using bat-friendly angle iron gates, all kinds of cool things. Wildlife and prescribed fire management to improve habitat, and really what's important here tonight is water quality monitoring to ensure the Buffalo River and its tributaries remain clean and clear. Chuck, you want to come on up here and give your great talk? We weren't expecting this one. Let me see if I can fix this really quick.
There we go. Set up. Now it's slideshow. Play from start.
Oh, and then I didn't turn my phone off.
Let me mess with it.
Yeah, sorry about that.
Nope, that wasn't it either.
Can you work with it that way?
I'll figure something out.
It's wanting to show a much smaller version of the presentation.
All right, we'll try. I may have to, we almost had it for a second. What if I do this? Nope, that doesn't work.
That's where we had it to start with.
Oh, well. No, I'd like to figure this thing out.
No.
Oh,
Yeah, his.
I am seeing that, and I can deal with that, except,
Well, it's when you had this, it was full screen for that.
okay, sorry.
Can you work with that?
I'll try. Wow, it's good to see all you here. I didn't expect this big of a turnout. As Teresa says, I've been with the Buffalo National River for going on 28 years now. So I've been there a while. I haven't been doing water quality work in a number of years. Farron Usry, our aquatic ecologist, actually put a presentation together on the E. coli he's been studying, and I made it much shorter and where I could talk about it because he had big words I don't know. So I want to talk a little bit you know, we've been getting a little bit of pushback, the National Park Service. We've been getting a lot of pushback from certain groups. You know, what are you doing? It's none of your business. I'm here to tell you it is our business. As you can see, this is Public Law 92-237. You know, Richard Nixon signed this law. Most of you remember him. When Congress established the National River, we were to conserve and interpret an area containing unique scenic and scientific features and preserve as a free-flowing stream the Buffalo River for the benefit and the enjoyment of present and future generations. And that's what we're about. That is our job. So, to put it in non-congressional language, we're there to protect the Buffalo River, these unique scenic and scientific features from harm and destruction, so that other people can enjoy and benefit from it through recreation or other means. Oh, well, this thing. It works. All right. I can't see this little screen. I'm sorry. I got to kind of look over here. So what are these unique scenic and scientific features? Beautiful bluffs, a beautiful, clear, clean river, clean air, wildlife. It's a blue ribbon smallmouth bass stream. Caves. Did you know that Buffalo River has almost 400 documented caves? The longest one's 16 miles long, documented miles of passage. The shorter ones are much shorter. I won't talk about them. But we have a number of caves that have over a mile of documented passage, and there's very few national park units in the entire nation that have more documented caves in Buffalo River, but we're only about 96,000 acres. Grand Canyon's got more, but Grand Canyon's huge. And Grand Canyon has a lot more staff, too, that are out there actively looking. We've got prehistoric and historic features, a lot of bluff shelters, prehistoric bluff shelters, a lot of springs that were used prehistorically by people and historically. And in fact, there's still a lot of people in our watershed that drink out of their spring. So, something to remember. So, providing benefit and enjoyment is through recreation. Now, we're all really busy, right? We're all really busy, and we all need a break from our day-to-day grind. We need to get out. We need to experience some peace, some quiet, some solitude. Maybe get out and float down the river in a boat, or swim, or fall out of a boat, or whatever. Recreation, the root is to renew, to recreate oneself. That's what we're here for, one of the things. We also, some people get this through the study of natural things or man-made things. They get this recreation or this break from their natural grind. And other people just like to hear about things or see pictures or whatever, but that's all fine. We provide quite a lot of economic benefit. You know, it's great if you've got a national park. It should be great if you've got a national park in your state or in your area, because typically there are those people that try to, you know, go to every national park in the country and maybe the world. But there's a lot of people that just come to them. The latest data I can find, calendar year 2013, 1.1 million visitors to the river. Almost 800,000 of those were from the non-local area. I'm not exactly sure what that means, if it's just the counties that are in contiguous or the local, but anyway, it's a lot of people. $46 million. That's a lot of money. 637 jobs. That's not bad. And then the income that derived from this, $16 million of income after you take all the costs of doing business. Not bad. I wish I had a 95,000 acre farm that could produce that kind of an income. So we have all kinds of activities, as you can imagine: canoeing, camping, caving, hiking. Not so much caving anymore, unfortunately, because of white nose syndrome, but someday, I hope we'll find a way around that. Our peak water use period, mainly canoeing, April through August, because usually the river gets really low in August. This year we've had a lot more water. I think we've had a lot more river use this year, and when the numbers come out from that, we will see a big spike this year. We know river use causes impacts because there's a lot of people congregated. There's people canoeing down the river. You know, they got to answer the call of nature too. We want to educate people to go up into the vegetated zone to do their business. Not everybody takes to education equally. We understand that. But proven fact, most of the pollution comes from tributaries. And it's not just the Buffalo River, it's pretty much any river, because we're 11% of the watershed, and the other 89% of the watershed, a good bit of it's agricultural land, got a lot of manure and so forth that can wash off, a lot of sediment. So that's a possible issue. We started monitoring water quality about 1985. Dr. Joe Nix at Ouachita Baptist University came up and did a float down the river, kind of did an inaugural study, and he assisted us in the first several years getting our program up and going. We would collect water samples and send them off to Ouachita Baptist to Arkadelphia, and he would send us results. Along about the late 80s, we started working with ADEQ Water Lab. Martin Maynor was the water chief down there, and Dick Cassette was the head of the water lab, and we had a really good working relationship with them. And we would send them samples down, and we've been doing that now since, 1989-ish, so we're getting close to 30 years. Of course, ADEQ is responsible for the Clean Water Act in Arkansas, at least a good part of it, the water quality standards. We monitor based on ADEQ's Regulation Number 2 standards. So Regulation 2 covers the water quality. Originally, when we started this, we wanted to see what is the health of the river, what's the health of the tributaries. But now we're seeing some issues, and now we're thinking, okay, what's that impact on our visitors? And in 2009, we added E. coli sampling at the request of ADEQ. I'm just going to show you some numbers here, and I'm really going to go through them fast, I think. Geometric mean, primary contact water. I'm not even going to worry with the secondary contact water because we have water-based recreation all year. We want to have a very high standard for our water. We don't always attain it, of course, but we want to have a goal that I think we can attain, hopefully, and we want to protect our visitors from waterborne illness. So a geometric mean, that's 5 samples in a 30-day period. They should be spaced out evenly, which is kind of difficult sometimes. 126 colonies of bacteria per 100 milliliters of water. Basically, you take all 5 samples, this one's got 10, this one's got 400, et cetera, et cetera. You add up the total, add it up, sum it, and divide by 5, and that's your geometric mean, essentially. And 126 colonies per 100 milliliter is, when it exceeds that, then we're out of compliance. So Dane did an excellent job talking about the swine CAFO. I don't think I have to talk about it. I have some different numbers than she has, different sources. My numbers come from the notice of intent that C&H Hog Farm Incorporated filed when they applied for their permit. So my calculations tell me that there's like 4.2 million gallons annually of waste. This untreated waste is not, this waste is untreated. It sits in those lagoons. So there's really no aerobic activity, like a lot of sewer treatment plants, they turn that waste over real fast. They pump air. It's always churning. And there are bacteria that actually break that waste down pretty effectively. But that's proven technology. So the untreated waste is land applied, and they tell you 630 acres in their notice of intent, but there's 2 fields that they didn't have permission to apply on that were in their permit or their application. And then there's buffers for streams. There's buffers for lots of things, roads, nearby houses. So when I ran through all the buffers, I came up with about 400 acres available. 92% of these acres are directly underlain with karst. The Boone limestone, the most cave-rich limestone in all of northern Arkansas, in the most cave-rich county in the entire state, underlies 92% of these 400 acres. 43% of the fields are in the floodplain of Big Creek and Dry Creek. And when the 5,000 acres per day, or 5,000 gallons per acre per day of seepage, if the lagoons are filled, from my calculations, they would be allowed to leak almost 6,500 gallons a day. First land application manure was December of 2013. Now, so what? Why do we care? Well, we care because we care about clean water, clean air, wildlife, fisheries, cave and karst systems, prehistoric and historic structures, and we care about these things, these people. Because without the people enjoying the river, if the river becomes too polluted for primary contact, what's the point of having it? There's been national parks deauthorized before, at least a couple I can think of, or national monument, national park areas. We don't want that to happen in Arkansas, do we? You're upside down. No. Okay, we're concerned about public health, and you can read a lot about public health, E. coli, cryptosporidium, et cetera, can be a big problem. We share a lot of germs with our animals that we've been around for 10,000 years or more. So we've been monitoring this E. coli essentially weekly for since March of last year. That's where I want to get to. Little CAFOs here, Buffalo River's here. Here's our boundary. This shows single sample grabs for E. coli. Manure application began right here from CNH. We suddenly started getting huge spikes in Big Creek this year. But even more telling, really, much less volatile data are these geometric means. Manure application to the fields began here. Waste began filling the ponds back here, I'd say, but I don't know that for sure. This geometric mean, Big Creek for the month of April, almost 500 colonies, dropped down to just on the line in May, shot back up in June, started tapering off. But notice here, this blue line's the Big Creek above, is the Buffalo River above Big Creek. The green line is the Buffalo River below Big Creek. That E. coli coming in to the river pushed the Buffalo River out of compliance. We're concerned. Basically, I don't know, but basically Big Creek doubles the E. coli exposure risk in the Buffalo River, 6 to 13% of the sample period. And we saw Big Creek was above the recreational contact for 2 months. We're going to continue monitoring Big Creek. I don't know when we're going to get to quit. And I'll just be frank with you, this is a project that was thrust upon us. We had no choice. than to monitor. I guess we could have just not monitored and said, well, we'll just see what happens, you know. But we really have an obligation, so I'll answer questions later on when I sit at the table. If there's any, be thinking about them. I'll try to answer your questions. And thank you all very much for coming here tonight.
Our next speaker is Victor Rowland. Victor Rowland is a PhD student at the University of Arkansas in the Environmental Dynamics program. Victor completed his ME and BS in Environmental and Civil Engineering at Tennessee State University in Nashville, Tennessee. He works with the U.S. Geological Survey, Arkansas Water Science Center as a hydrologist in training. Victor is conducting research on water quality, microbial biofilms, hydrogeology, and natural and engineered contaminant remediation methods. And today he's going to present on some of his information on antibiotics. Thank you, Victor. Can you read this?
Yeah.
Okay.
Hi, how's everyone doing? All right. So, as I was already said, I am Victor Rowland. I'm with the USGS and University of Arkansas. And this is some work that I'm presenting here based on a study that originated out of the Tennessee Water Science Center, where we were interested in coming up with some background levels of antibiotics in the environment. So the purpose of the study for us was to look at the activity within bacterial biofilms to assess the changing water quality in the surface water and in the groundwater. And some of the questions that we had specifically, what are the effects of dissolved organic carbon? Since we know that associated with a bunch of hog manure, you will also see more organic carbon. So that's one thing that we wanted to look at and say, well, what is that going to do with the actual production or the activity within the bacterial biofilms? What are the effects of antibiotics? Specifically, antibiotic resistance. That's the major concern when you start talking about antibiotics. Are you developing antibiotic-resistant bacteria there within the watershed? Then, do heavy metals actually have an impact? Can they trigger some of those antibiotic resistance mechanisms that you would see in some of these bacterial biofilms associated with antibiotics, but they're actually being triggered by heavy metals? So that's another thing that we wanted to look at. So antibiotics, they're used to promote the growth and to prevent disease when you have a lot of hogs concentrated in a small area. Associated with the occurrence of antibiotics is antibiotic resistance. There have been several studies that have showed that where there are antibiotics in the water, there also tends to be an increased concentration or an increased occurrence of antibiotic-resistant bacteria. So, one thing that we need to really come to terms with, and was a spearhead for this, as I've already stated, we don't know exactly how many antibiotics, the concentrations of antibiotics in the environment. So we have to start off with actually being able to identify or to say, well, this is the baseline, this is the background level of antibiotics within groundwater or within surface water. Now, in CAFOs, farmers are not directly responsible for saying this is how much of this antibiotic I use for this particular animal. Only thing that numbers that we really have to go based on are the sale and the distribution of antibiotics here in the United States. So the US FDA puts out a report, and what I'm showing here behind me is that report, and it's showing the actual mass of antibiotics that are distributed or sold in the United States. Now, ionospores, macrolides, tetracyclines, 5 million kilograms of tetracycline antibiotics distributed or sold here in the United States. 4 billion with the ionophores. Now, there are several types of antibiotics within these. These are major classes, but this is the best data that we have to go on in terms of what could be actually getting out into the environment. What is also worthy of noting, NIR. Those are antibiotics that have not been approved by the FDA. So the rest of these are approved antibiotics. So once the antibiotics is administered to the hog, there's a pathway. We understand from several studies that only approximately 10% of those antibiotics administered to the hogs or administered to the cattle is actually metabolized by the cattle or the hog. So that leaves approximately 80 to 90% that is being released from the animal into the excrement and into the environment. Once it hits the environment, we've already discussed the lagoon ponds, we've discussed the application of the waste, the liquid waste and the sludge to the application fields. So then you have a situation where you have terrestrial organisms that are being exposed to the antibiotics, but then you also have the liquid or dissolved antibiotics that are infiltrating through the soil. And then when we're in a karst situation or a karst environment, such as near the Buffalo River and in Mount Judy, we end up with infiltration down into the groundwater as well. So now we have antibiotics that could possibly be transported in the groundwater, and then in situations such as karst, where you have a high level of exchange between groundwater and surface water, you also have the potential for those antibiotics to reach the surface water. Biofilms. Many of you guys may not have heard of this term before, but biofilms are just a group of bacteria that are living together. They've attached to the surface, so they're no longer swimming around as you would normally expect, such as kind of what Chuck was talking about. They're looking at bacteria that are actually loose in the water, free swimming. I'm looking at attached bacteria here in this situation. So when you hear about biofilms, that's what we're talking about. So in their growth, they'll start off here in the water. Those single cells will drop out and attach to the surface. They'll congregate, they'll reproduce. So you have more bacteria that are actually growing at the surface, but then you also have different bacteria. So you're not looking at just one type of bacteria growing within a biofilm. You're actually looking at a whole system of bacteria with different functions as well. And so those bacteria are acting in symbiosis. So they're exchanging food with one another. So that's one advantage of being in a biofilm. But they also provide protection. Those biofilms, bacteria are also targeted by protozoa. They like to eat them. And so those protozoa are targeting these bacteria. They're harder to target when they're in biofilms together in colonies, and it's difficult to actually isolate any particular bacterial community. So those are two main things or main reasons, advantages that bacteria have forming biofilms. They are also able to self-preserve. So they exchange genetic information within these biofilms. That genetic information, such as, for instance, antibiotic resistance, can be exchanged between different communities of bacteria. Those different communities of bacteria then move on once that biofilm has matured. It thickens to a point where it can't hold on anymore, and then you have the distribution of those bacteria, of the genetic information associated with that bacteria through the water system, through the flow system. So we conducted some laboratory studies. We set up small models within the laboratory using water that we collected from Big Creek, from the Buffalo River, and from a spring. We actually added some food to those small models, or we call them microcosms. We added food to them, so we added some nutrients, nitrogen and phosphorus. Then we also gave them a carbon source, something to kind of speed up or edge on the process of what they would normally be doing in the environment. We analyzed them for carbon, nitrogen, phosphorus, and dissolved oxygen. So those are our indicators of how active are the bacteria here in these systems. As I said, we added food. We use isotope labels kind of commonly. And what the isotope labels allow us to do is to trace the bacterial processes that are actually occurring. So things such as nitrification, denitrification, the bacteria removing nitrogen from the system, the bacteria adding different forms of nitrogen, removing carbon from the system. we use those types of tracers to say, well, this is how much of this is happening. We also conducted some antibiotic sampling this summer. This here, we're waiting still for the data to come back from the USGS Organic Geochemistry Lab in Lawrence, Kansas. But we're going to look at 4 different types of antibiotics, 4 different classes of antibiotics. So we're going to look at our macrolides, specifically erythromycin, and then we're going to look at tetracycline. Now, 2 major points about these. These are naturally produced antibiotic compounds. So there is already probably going to be a natural resistance within the environment that you will be able to detect. So that's one thing that we have to be careful about when we try to source and say attribute these occurrence of these antibiotics to whatever source it might be. Then we looked at sulfonamides and fluoroquinolones, are what they're called. But each one of these different classes of antibiotics have different mechanisms that make them active. The sulfonamides and the fluoroquinolones, they're synthetics. So they're man-made, but they happen to be pretty mobile in the environment. So they are of a particular interest, and as far as it comes down to where they're coming from. Sampling locations, we sampled from upstream and downstream of Big Creek entering into the Buffalo River, and then we sampled Big Creek upstream and downstream of the CAFO. The last test that we actually did was antibiotic dose response. So we grew some of the bacteria that we were able to sample from the fields when we were doing our antibiotic sampling. We brought them back to the lab, grew them on Petri dishes, exposed them to some of these antibiotic compounds that I just mentioned, mainly erythromycin and tetracycline. The plates were inoculated with that water that we collected out of when we were sampling, and then the bacteria were counted 48 hours later. Here, you're able to see a graph that's showing the concentrations of the antibiotic across the bottom, and then also how many bacteria we were actually able to grow. The general idea here from this picture is that as you move up in concentration for the antibiotic, you actually see that it's inhibiting the growth of the bacteria. So on one hand, they are effective, and these bacteria that we were actually able to grow in the lab are affected and not resistant up to a certain level. However, what you actually culture in the lab is not exactly what you see in the water. So there's only a fraction of the bacteria that's in the water that you'll be able to grow in the lab. You won't be able to grow all of it. Here's a picture of the actual plates. And here I'm looking at the Buffalo River upstream of the Big Creek confluence, and then the Buffalo River downstream of the Big Creek confluence. On the left is erythromycin, on the right is tetracycline for both. And the general idea, I don't know if you can see it, but just downstream of the Buffalo River, we see that we have a lot more bacteria growing. We have a lot more counts of bacterial colonies growing. Also, we see that up to 10 milligrams per liter, we actually have bacteria that are growing healthy, seemingly. So there could be an indicator of some type of resistance there, but we still need to collect more data to actually be able to say that. We also need the data on the concentrations of the antibiotics that are there in the water as well before we attribute any resistance to it. It could just be a matter of natural variability. Then we see erythromycin, same general trend. The concentrations of the erythromycin of the antibiotic go up. We see the concentrations of the actual bacteria, the bacteria that are able to grow, go down. Now, these are 2 different samples. One is from Big Creek at Carver, so this is going to be downstream of the hog farm. And then we have Dye Spring, which is a spring that is coming off of some of the application fields. So it's actually acting as a basin. It's capturing all of that, concentrating it, coming down through the spring. So that's also the same spot where we've studied our water chemistry and measured some of the highest levels of nutrients there, nitrogen, phosphorus. All of our highest concentrations of E. coli that we've measured have been highest coming out of Dye Spring. So you see Dye Spring has a pretty healthy amount of bacteria that we were able to culture, up to 10 milligrams per liter, resistant to the erythromycin. So there's a possibility that there could be a natural source, a natural resistance there in that case, or there's a possibility that that could be a component possibly that we'll be targeting in future studies. Big Creek, downstream of Carver, we kind of see the same situation going on. However, the tetracycline resistance cuts off at 10 milligrams per liter. So what would we like to do in the future? In the future, we like to identify the changing bacterial populations. This water is going to be changing. The water quality is changing. We like to identify what type of shifts will we actually see within the bacteria that are living there. One moment we may have more nitrifying bacteria. The next moment we may have less. One moment we may have more resistant bacteria, and then we actually have less resistant bacteria as a consequence of the antibiotic compound leaving the watershed. Investigate the potential of bacteria to exchange antibiotic resistance. This is getting back to the idea of looking at within those biofilms, what's the probability of the bacteria to exchange antibiotic resistance between communities? So bacteria that were not resistant becoming resistant. That's one thing that we want to look at. We feel like that's going to be a major issue going forward. Identify factors affecting the movement. So all of that additional dissolved organic matter that's coming in from the application, will that actually aid in moving around some of these antibiotic resistance mechanisms to different communities of bacteria? Metals associated with the swine manure, will that aid in the transference of these antibiotic resistances? So those are the things that we plan to work on in the future, and that's all I have. If you have any more questions, feel free to ask me later.
Thank you, Victor. That was great. Our next speaker is Dr. Van Brahana. Oops, you were just short of time. Dr. Brahana received his formal education, groundwater geology, from the University of Illinois and the University of Missouri. He has more than 50 years of groundwater teaching and research experience with state agencies, the Illinois State Geology Survey, federal agencies such as the USGS, universities such as University of Southern Mississippi, Vanderbilt University, University of Arkansas, consulting, and local, regional, and national technical review boards and consortia. He's also, I happen to know this, he's also published over 75 peer-reviewed journal articles, so he's done quite a bit of work. He's been around a long time, and also with Tom Sawyer at USDA ARS, he was active in initiating and instrumenting the Savoy Experimental Watershed, which is a division of agriculture site that studied the long-term impacts of sustainable animal production on karst land. This past year, he has actively conducted and supervised a range of pro bono field studies to describe in detail the karst hydrology of the Big Creek Basin, which is a major tributary of the Buffalo National River, the site of our 6,500 pig CAFO. Although retired, and he is the most active retired fellow that I know, he is active in consulting, volunteering, technical hydrogeological advisory, and review boards. So come on up here, Van. Well, this is the problem that we're having. Can you do about that?
That's good. You've heard the word karst before. What karst refers to is land that is underlain by soluble rocks, dissolvable limestones, dolomites, other types of rocks. And the importance of studying this, the importance of understanding this, as we've already had described, is that this represents a huge component of the basin that Big Creek lies in. Here's what happens. The streams, this is a stream, we're putting dye in, and it goes into a soluble sinkhole. It sinks down on the order of 10 to 15 feet, and it moves laterally. It's like a Swiss cheese. It is not something that we can see easily, but the fact of the matter is that water is flowing dynamically, it's moving ever downhill, and it is coming out in springs and rivers. So we're going to conduct a series of dye trace studies, and I want to talk about those then. Most of the focus in groundwater and surface water interaction in karst shows that the water, it goes in multiple locations. It comes out multiple locations. Where it comes out, those are called springs. The springs in Big Creek Basin pop up in the middle of the creek. They pop up on the sides. There are some huge springs further, closer down by the Buffalo, but that water is dynamically moving, and that's an important consideration. I'm going to focus on the second item, but these are other studies that are actually going on by volunteers in a variety of, our group sponsored by a variety of people just exactly like you. And these attributes are important. I'm going to show you one final picture that we're going to talk about some worms. You need to increase your understanding of worms and the quality of how they impact water. You've seen this map before. I won't dwell on it, but the area that's shown in brown is the region that includes this Boone Formation. It is a thick layer. It's approximately 350 feet thick. It includes pure limestone. There, in the middle of the formation, there are multiple layers of chert. Chert is also known as flint, and that flint is very resistant to being dissolved, so it doesn't get dissolved easily at all, and it also impedes the vertical movement of water downward until we reach cracks and fractures. And then if we have faulting in the area, which we do in the Buffalo National River because it's been uplifted, then we will have interaction from that. And the area of Big Creek is essentially in this region right here. This is another view of the same component, but it's close to the upper spreading fields. These are features that we had to go out and find. Some of these are proximate to or very close to the National Forest land. In any case, these pure limestone units develop beautiful sinkholes, and they can capture the entire flow of this stream upstream from here. It's going down, and typically it may flow a short distance, pop back up as a big spring, but nonetheless, it is transporting the water. And since it's being transformed and transported underground, we need a means to know where it goes in and where it comes out. Those are things we can't visually observe directly like we can from a creek or a river. This is a view of these layers of the chert. This is looking up a steep, steep bluff over in Newton County, which is the home of this particular CAFO. And you can see these layers of chert alter the direction of flow. If they're uplifted and tilted a little bit, that will control the flow. And the reason I'm spending a little time on this with you is the fact that we're seeing unbelievable flow directions and dispersion of water moving out from where we have actually input dye in the ground. Here's what those caves, those cavernas, we have some French visitors who are filming. We have a variety of other components going on. This is 3 centimeters. That's 3 centimeters. That's a small opening because the thickness of the limestone between these 2 chert layers is also relatively thin in this part of the formation. But these guys are just like miniature pipes, and they can haul a bunch of water. They can move the water very fast, very quickly, and they can transmit it very, very large amounts of it. As a caver, I would like to share, Chuck Bidding has been able to capture some of these images. Newton County has some of the most beautiful, spectacular caves in the state. But this is one of the caves that we have positive dye results that lies close to the Buffalo River, downstream, and it's outside the drainage basin of Big Creek. But when we put the dye in within one of our input sites, it came out at this particular location. And you can see some of the features we put. Sometimes the dye shows very bright colors. Other times, typically when we're putting the dye in, we try to minimize that unless we want to get the attention of some of the factory farms. Here's what the dye looks like. Different colors, we have multiple colors, but the reason we use these dyes, I could use radioactive waste, I could use uranium, plutonium, it would show up. But the fact is, these are non-toxic, they are not dangerous to the ecology of the region, they are very beneficial, and when we capture these, we can put these, the dye receptors we use look like little tea bags, and they're filled with charcoal that comes specifically from coconuts, and as the dye moves past, it attaches to these. So we can put these in and we can come back weeks later, sometimes even later than that if we want, and if there has been dye that has passed that site, we have a connection. We have a positive connection. And that allows us to understand where some of these locations are that the flow system is coming out. And we're going to, we'll dance with that for a few moments. I want to do a comparison. When I talk to some of the groups that include the Farm Bureau and so forth, they say, well, you're putting water into, typically the injection points are into sinkholes. Sometimes they're into dug wells. But these wells are on the order of, some of the wells are as deep as 35 feet. But when we put, their claim is you're bypassing all of this cleansing action of the soil above this. Well, the fact of the matter is, what I want to show you is this represents Big Creek. These are 4-day intervals, so that's a pretty tight timeline. And here's what we have. I drew some vertical blips where we got big rainfalls, and some of these components, if I shift back just a little bit, essentially the response of the surface water is as rapid as the response of the well is. The water level in the well goes up. I do not have enough money to put enough dye over those spreading fields to get it down into the ground. This particular figure tells me that that is a very rapid time frame. There's close interaction. It may not occur at every spreading field, but it occurs within the area very well. And this, in my opinion, documents it. And those are data that we have collected every 5 minutes since we started last. I guess that went in about last November. We also have, I want to look at the response to rainfall, and here's some of the rainfall data just to give you a sense. These are dynamic systems, and the things that I don't do rocket science, guys. I just study the movement of water, and essentially water flows downhill, and it follows the path of least resistance. And you know everything that I know about hydrology. But I want to interpret very quickly, and this is, you're going to get a karst hydrogeology lesson in just a heartbeat. This says the chert layers, we're back to those layers. They're not very thick, but they're flint layers that extend for literally miles in any direction, and we believe they came from ash, volcanic ash, when the Washdaws formed. And in any case, look at this straight line connection in that particular water level. This is a well that we injected dye into, and when it rains, the water level goes up, and it goes up very rapidly. Then it falls, but the angle, the slope, the rate of time, and these are time in hours, it's different. And in this particular case, if we look at this, here's some other data here. This is a very, very slow release at the bottom of the well. It's like a cistern that has been dug out, and it's a cistern. When I put dye in, the reason, and I'm going to show you in just a minute what the results were, but the reason this particular location or interpretation is so meaningful to us is this. When we're at this level, there is no dye moving out. It's not moving out laterally. It's sitting there. We got 0 results, 0 hits from mid-August through October because the water level in the well was low. But when it was high, let's go back and look at some of these figures. I'll put these all up like this. There is another level here. This break, it's a slight variation in the slope, how fast the water is getting out. And it's dropping rapidly. It's screaming through there. This is probably the main outlet for it's opening those mini caves that I talked about, but it's moving out laterally, and it's moving out very rapidly. Then there's a slow release, and there's some other components there that I don't want to dwell on, but I do want you to know. These help us understand a very complex flow system, and with that in mind, then there are some of these peaks. This particular one appears to be transporting a lot of water as well. Anyway, let's go on with what I want you to see. Preliminary results. Here's the CAFO, and I'm going to show you. This is a geologic map. The area that's shown in the flesh color is the Boone Formation. That's the karst-forming formation. Above it, these are hills of sandstone and shale, and they act like an umbrella. The water that falls on them is shed off to the side, and the wells don't respond very much. But here are the areas of the spreading fields, these sort of orange areas. And let's look at some of our preliminary data. We put dye in here just across the road from the pig farm. I wonder why I didn't put it in. Why didn't I put it in the pig farm? Well, I'll tell you why. They don't let me onto their property. They hate my guts. It's okay. It's okay. I can live with it. Anyway, multiple components, those green arrows, These particular dyes each have a fingerprint. When I put them in the charcoal packet, I mix them with mostly alcohol and some other chemicals, but the alcohol knocks the dye off, and then I put that knocked off dye in a machine, and it gives me a fingerprint, and I get a signature that is unique to that specific dye. It's very narrow, it's based on the wavelength of the dye, and it's scientifically very sound, and it's based on many, many studies that researchers have done. Okay, so that's one, and then what happens? Then we pick it up. This is Big Creek. This is left fork of Big Creek. This is a topographic divide. This is a hill. In some cases, it's 1,200, 1,500, 1,800 feet high. Up in here, it's not so high, but it's a hill. And I want to show you what happened to some of the other dye injections. We put a red dye in this location, and I never found out where it went. We never retrieved any part of it. I'll discuss that a little later. Then we put dye in this location between these three spreading fields. And this is the site. When we put the dye in, approximately 2 days later, there was a huge rainfall event. It raised the water level in the well, and the dye was hauling. It was going all over the place. And I want to share those with you now. We have some that came down here. We have some dye over in this Seven Spring area between these two arrows that came out. It's a much larger spring than we would expect in this particular area. So it suggests it draws water from a much larger area. The spring is between. It's just like those mini cave pictures I showed you. It's those voids that come out right into the left fork of Big Creek, the major tributary. But it's coming out. And then as we trace it downstream, there are, here's some velocity terms, 3.5 miles in 7 days, 2,500, 3,000 feet a day. And those are consistent with some of the other data that we have, and then they're going downstream. I want to show you the summary diagram that we just put together. Katarina Kocic just put this map together. Katarina's working on her PhD from Slovenia, which has some of the most spectacular karst in the world. But look at all of those positive hits. Here's the buffalo. Whoa, we're getting dye down on the buffalo at these locations. Now, this is dye. It is not necessarily pig waste, but my contention is that the pathways exist. The pathways are there. And if it can transport these features, it also can transport those pieces of dye that are the same approach. The arrow or the triangle shows where we put the dye in. Here are the spreading fields, but we got dye in wells. We put some of these packets, these dye receptor packets, in toilets, the back of toilets, because people utilize their wells to flush their toilets, and it recycles it dynamically. It's coming out of the wells in this area. It's not just the springs. It's water that these people use for a variety of applications, some for drinking. So with that in mind, these concentrations after mid-August, zero dye. The dye there's still dye in this particular well. It's down in the bottom. It's a little more dense. We're going to go back in and do a very thorough study to add water, to flush it out, and to move it again. But the fact of the matter is, this describes a range of where the water goes. So here's the summary of dye testing. The velocities are very fast. The groundwater velocities generally are 10 feet a year, 20 feet a day is very fast in most cases. 1,500, 1,700, 2,500 feet per day, that is close to surface water. It's dispersive. The flow is spreading around. It gets tilted. It moves down these chert layers. And if there's a slight tilt to that layer, just like if I had a Pepsi Cola here on the countertop, and it's got a slope, check out the slope, and I spilled it, what direction is it going to go? Straight down the slope. So those concepts, the fact that it disperses, the fact that it moves around, the fact that it doesn't just go to one place is amazing, but it is popping out everywhere. And there are a variety of other aspects, but this tells us where we need to sample for more water quality data that is going to have the fingerprint component that hopefully will get us to evaluate the distribution. The hog is the hog farm truly contaminating the buffalo? One final picture. I told you I was going to share some worm pictures with you. These guys are Platyhelminthes. They're also, in this particular case, Dara vega is the name of the worms. I've been around, I've floated the buffalo with my classes for 20-some years. I have never seen a occurrence of organisms like this, and you can't see it in this image in enlargement, or I will send me an email and I'll send you this picture and you can check it out. I need to know what these organisms are, where they are from, how they form. They are probably, I was told by the biologist who identified them, Dr. Steve Beaupre, that overall they like to feast on organic matter such as pig manure. It doesn't have to be pig manure, but it is consistent. A lot of these measurements we make are consistent. So here's the summary. The data that we have collected, the data you've heard from Dane, the data you've heard from Chuck, the data that you've heard from Victor, all of these pieces of information are consistent. There isn't a single one yet that's a smoking gun, but if we keep looking for it, by golly, I contend we're going to find it. And the final point I want to make is we owe all of the contribution of the people with whom I work is amazing. They give their time, their money, their own fuel to go over to the buffalo, and it ain't a bad job, let me tell you, and I don't mind it so much, but these come from all over the place. Joe Nix is a college professor, a man who worked for ADEQ and environmental consulting down in Little Rock. Teresa worked for NOAA, spectacular interaction. Here's Chuck and Chuck's wife, Carol, who gets us entry to these farmers whose lives have been severely disrupted. The cities themselves, the towns themselves where CAFOs go in, they're fractured. It's an us versus them mentality. Instead of sitting and talking together and trying to resolve and get to some meaningful answers, we just snipe at each other. Well, in any case, look at all, and students and the people who've donated, Don Nelms, the Ozark Society, the Buffalo River Alliance, private people, all of these people have made contributions, and everything contributes to the science. So thank you very much, and I'll be glad to join the crowd.
Our next speaker is Anna Weeks. Anna is the Environmental Policy Associate for the Arkansas Public Policy Panel. She's out of Little Rock. In her position, she develops the overall strategy for the organization. She mobilizes people and does the policy work around environmental issues, including clean water, clean energy, energy efficiency, and more. She helps the Citizens First Congress coordinate campaigns for environmental policy changes and conducts public outreach to educate Arkansans about environmental issues. Anna has a strong background in environmental policy and experience in coordinating campaigns and outreach. She's done extensive policy and legal research in the nonprofit, for-profit, and government sectors. Anna has a JD from the University of Arkansas School of Law and a BA in Environmental Studies from the University of North Carolina. Come on up, Anna.
Yeah.
Okay.
That's right.
All right, let's see if you...
All right. Good evening. Can you guys hear me? Great. I want to thank you for having me here, and I can't stress how important the science is that all of our presenters here have been working on, and to move forward in the legal and administrative and legislative areas, the science is really what we need to back us up. And I'm going to give a brief update on where we are really in the administrative and legislative process. And I know it's the end of the evening, and administrative law lesson is what everybody's looking forward to. But I'll try to be quick. So there's two regulations, Dane touched on this, that govern the permitting process for CAFOs. And they are Regulation 5 and Regulation 6 with the Arkansas Pollution Control and Ecology Commission. In the past year, there's been two separate rulemaking processes going on to change these, to change Regulation 5 and to change Regulation 5 and 6 together. So there was one, an Act 1511 that was passed at the legislature in 2013 that proposed changes to the notification procedures that have to be followed when somebody applies under the general permit for a CAFO. And this was brought up really to alleviate the issue that Dane touched on, that everybody was really surprised about this CAFO going in. And so these changes would really help alleviate that. The other rulemaking is one that the Arkansas Public Policy has partnered with the Ozark Society on, and that is to ban any new medium and large swine CAFOs in the Buffalo watershed. And so I'll talk about both of those a little bit and where we are. This is the administrative process for making any changes to the current regulations. And so first, you have to file a packet with the PSC. There's a petition. The Pollution Control and Ecology Commission has to initiate your petition, and then you can move forward with the public comment period. After that, it has to go through legislative review, which they just have to review it. They don't really have to approve it. And I'll touch on this a little bit later, why that's important. And then it goes back to the Pollution Control and Ecology Commission for final adoption. So I'm going to first talk about the Act 1511 and the notification procedures. And that one has been adopted. It's gone through the rulemaking process and is currently in place. And so this was, it started about the same time as our rulemaking process in the spring. And what it does is to change the notification procedures. So before, it was just published on ADQ's website, and now this will give the public greater notice. The committee that was created had, it's hard for me to read on here, so I'm going to have to turn around. It had representatives from each of these organizations, one from ADQ, one from the Ag Department, one from Farm Bureau, and then two appointees by the governor. And they came up with recommendations that were adopted in whole. There were some public comments that were presented to change these, and they were actually all in favor of these, but to increase the public notification was the only other comment. You're having a hard time hearing? Um, the new notification procedures, is that better? The new notification procedures require that notice be provided to property owners adjacent to the CAFOs. The county judge will also receive written notice. Mayors of any municipalities within 10 miles of the site will receive written notification, and any superintendents of schools in that area will also receive written notification. The Department of Environmental Quality will provide the contents for this notification, that it will have the location of the farm, the address, the name. It will also talk about the public comment period and how people can make a comment, where they need to submit their comments, who they should contact at the Department of Environmental Quality if they have any questions or want more information, and also how they can get on a list to receive electronic notification of any other notice of intents that are submitted. The applicant must also publish one time in the local paper of greatest circulation their intent to have the CAFO, and then they also are required to post a sign at the closest public road to where the CAFO is going to be located. That's, I think, a 2x3 sign. And then when they submit their notice of intent, they have to prove that they have met all these requirements. So this really should help the public be more aware of when one is going in, that we shouldn't have any slip under the rug with this in place. The other regulation change that we've proposed, and this has not been adopted yet, that we are in the process right now, is to ban any new medium and large swine CAFOs in the Buffalo River watershed. And a lot of you probably know some of the background on this, and the medium and large was chosen that it's a federal number that is 750 or more swine that weigh 55 pounds or more, or 3,000 or more swine weighing less than 55 pounds. So these are large operations. CNH is the only one that has a general permit in the state currently. And so we feel like the Buffalo River, as has been stressed in the other presentations, is a special area of the state, and that there should not be any other hog farms placed there. So right now we've gone pretty far in the process. We've gone through the petition to initiate rulemaking. It started in April. The public comment period was held for 30 days over the summer, and over 2,000 comments were received. The Department of Environmental Quality has said that this is the most public comments they've received on any rulemaking change that they've had before, and 93% of those were in favor of the proposed changes. So we've got great bipartisan support on this. The next step is to go through the legislative review process, and we had our first hearing with what the rules require is to go to the Public Health and Labor Committee, and then once it goes through, is reviewed by them, then it goes to the Administrative Rules and Regs Committee. We had our hearing with the Public Health Committee, and they decided at that meeting not to review it, that they felt like it needed to be heard jointly with the Agricultural Committee. And so that's where we are right now, that those two committees don't have a regular meeting, and so we're trying to get them to schedule a meeting, and we don't know when that's going to be. Definitely not before elections. And so we were hoping that this coming Friday, the 24th, at the Pollution Control and Ecology Commission was really when we would be going for our final adoption. But we've hit this snag with the legislative review, and so we're waiting for those dates. The moratorium that was issued at the same time as when we proposed this change is going to expire on the 22nd. And so that moratorium does the same thing as this ban would, that it prohibits any new medium and large swine CAFOs from being permitted in the Buffalo River watershed. But it will expire on the 22nd. And since there haven't been any changes since we did our proposal, and the moratorium will expire, the Pollution Control and Ecology Commission's voting again this coming Friday to extend that moratorium for another 180 days. The last thing really that I wanted to talk about was the elections coming up. There is one on the ballot. There is SJR 7, which is an amendment that would change the rulemaking process. Where currently, during legislative review, it just has to be reviewed. It doesn't have to be approved by the committees. This constitutional amendment would change it to make it where the legislature would have to approve any changes to the regulation. And so currently, it doesn't happen very often, but the Pollution Control and Ecology Commission, for example, could go ahead and approve these changes without having the legislative approval. But it's uncommon that it happens, but it can happen. If this change takes place, then they wouldn't have that authority at all anymore. So that will be on the ballot and could possibly change the way this rulemaking goes through if it's depending on how long it's held up. So right now where we are is just waiting for we're not really waiting, we're encouraging the committees to set up a meeting together and move forward there. And we will take questions now, I believe. That's it.
Panelists, if you all can come up here and we'll take a seat right here and we'll actually pass the mic around. And Alice, I noticed you have a question. If you could come up here to the mic and so I'll try and repeat what you just said.
Okay.
So the Ozark Society has information back here on their table about the third-party rulemaking, and you all are allowed to pick some of that up if you'd like. People that have questions for the panelists, if you could come right up here to the microphone and stand in line and actually state your name and and who you're directing your question to, that would be very helpful. Also, before we get started on that, Jenny wants to raffle off the CAFO books. I have the drawing, excuse me. Okay. Okay. Here's one.
So 130824. No, you gotta look at your number.
130824. All right. Could we actually raise the lights? Whoever has control of the lights, could we turn those up a little bit? And then we have one more drawing. Congratulations, Tom.
Okay. And the next one is 130823.
Wow, how did that work out?
Okay. Same family? Forget it. One per family. 130780.
All right. Come on up, Diana. Okay, Lynn, you have something you'd like to announce.
Nah, it's not. Oh, 3 seconds.
Is it on?
I'd like to ask people to, there are a couple of things that you can do tonight if you're interested in being more involved in this. One of them is if you haven't taken one of the Post-it notes that's over there and added a brief message about why this issue is important to you, we're going to take a picture of that and maybe blow up sections of it and send it to people to show that they're, you know, how people feel about this in their own words. We also have signs that if you would like to have a yard sign, we have the pig signs at the back of the room. And Jenny, was that it?
Then I'd like to add a couple of things that I forgot initially. You know, this event is sponsored by Buffalo River Watershed Alliance and the Ozark River Stewards. And if you would like to make a donation to any of the groups back here, we're all working together, and we certainly would appreciate that. So that's my plug for money.
Hi, everybody. I'm Amy Wilson. I'm a resident of Fayetteville, and I'm glad to see everybody here tonight. Anna, this question is for Anna Weeks. You mentioned SJR 7 at the end of your talk, and I want to know how that's worded on the ballot to ensure that I vote for or against properly, because it seems to me that a lot of the ballot issues are worded in such a way to confuse the voter. And what I'm understanding is we want the procedure to stay the same as it is now, because right now something can pass and it doesn't have to go before a legislative committee before that agency, like the agency, Arkansas Department of Environmental Quality, can go ahead and put something into force, and now they can. So anyway, if you can ensure that I understand that.
Yeah, hi,
Thank
Amy.
you.
Good to see you.
You too. You too.
I'm not exactly sure how it's going to be. Can you hear me? How it's going to be worded on the ballot. That the one I need to look at a sample ballot and see that. I think it's going to be you can vote for or against SJR 7, and that it gives the legislature more authority over regulations that are currently housed with departments. And so however you want to vote is up to you. If you want to vote for or against.
So
I'm going to vote against SJR 7.
Thank you, Anna.
So, Anna, will the Arkansas Public Policy Panel be sending out an email kind of informing people of the way the ballot is structured and that sort of thing?
We currently have not taken any position or done any outreach on this issue, that it's a pretty esoteric issue that's been hard to explain, and we don't have the capacity at this point to really do much outreach on it. And there hasn't been, as far as I can tell, there hasn't been anybody pushing for or against it. I've seen it in a couple of, I think Farm Bureau had it in their election outreach material, and that's the only place that I've seen it. So other than that, it's just really going to be word of mouth. We'll send out probably a little email about it, but we're not doing any major outreach on it.
Yes, my name is Jeannie Parham. I'm from Fayetteville. So I think we were encouraged by Judge Price's temporary ruling. But I don't really understand, I'm not sure we all understand what an injunction against the Farm Services Agency actually means. And also, who will be performing this new environmental assessment that he has asked for also claiming that the original one was cursory, to say the least, given what the science that we've seen tonight. That's my first question, and this is obviously directed to you, Dwayne. And the other is that Rule 5? Rule 5, was that a 1 year, just a 2012 rule that ADEC unilaterally implemented that you showed on your original, your first slide?
The first question, the injunction would be to stop the farm enjoying the loan guarantee so that they would have to, I guess the loan construction that was made, they would stop getting any funding or have the loan, it would just stop the loan guarantees on it. Does that make sense? That would be the injunction, but because it's a, not a temporary, but it's not a final order.
Right.
So we really don't know, and my coalition members can correct me if they're listening to me here, but it's not a final order yet. And so we don't know we don't know what that means exactly. I wish I had a better answer for you, but we don't know what that means. He ordered the plaintiff and the defendant to submit briefs, and I think he gave some latitude there for our attorneys to present our arguments of what does that look like to us. So, and then the second question I think you asked was
Rule 5, which was, I hadn't heard that,
Okay.
along with the plasma arc and several other things tonight that
Okay.
all are new to us, but
Okay.
Rule 5.
well, what my understanding is, and Anna may be able to correct me, but when I was doing the research, this was promulgated in October of 2011. And I believe that the General 6 permit came down because of a result of a lawsuit, might have been between water keepers, but it was in 2008 that the federal government allowed states to take on a general permit process, which is the National Pollutant Discharge Elimination System. And so it gave the states a choice to choose the general permit, or they could use the state permit. The Reg 5, which is what was being used to regulate liquid waste, the Regulation 5. In October of 2011, because of duplicating and educational requirements as part of the state permit that were also going to be part of the general permit, ADEQ came in with stakeholder input, extensive industry input, saying you shouldn't be duplicating and you shouldn't have to get both permits. So they gave these operators a chance to take on a general permit of a larger size, which a large CAFO could do, would be to, instead of being regulated by a Reg 5, liquid waste, they were able to choose the general permit. And that was implemented, ADEQ implemented that in June of 2012. Don't know if that makes sense.
Yeah.
Okay.
Yeah, I think the frightening part of what you said was, with large industry support.
Yes.
Yeah.
Yes.
We get it.
Well, I guess probably most of what I have to say is in the form of comment, but anyone that wants to respond can. I do want to say that, I don't want to diminish any surrounding state, but I do believe it's most important ecological area probably for hundreds of miles in every direction, if you really want to get down to it. And I think with all the families that have been moved off their land through eminent domain, I think it's a little disingenuous for them to make such a big thing out of these farmers not having done anything wrong, because all them people that moved off through eminent domain didn't do anything wrong either.
Could you state your name, please, for us?
David Montague.
Okay, thank you.
And I am concerned that the land below the farm on Big Creek, when it comes up for sale, which it probably is going to do at some point for whatever reason, I don't believe anybody's going to want to move into that land to live and raise a family. I think it's going to be going to people that don't want to live there, that want to farm it, or and that's okay. But most land has people that do want to live on the land interspersed with the farming. It's not just all farming. I'm just concerned that it's just going to be all farming, and it's just going to, if it's.
Sir, do you have a question?
Well,
Because we're kind of running out of time.
right,
So
I understand.
uh,
I guess that's pretty much all I have to say. Seemed like I did have a question, but I think I've lost track of it.
all right, thank you.
My name is Dwayne Wolchin. I'm with the Ozark Society, and I'm questioning the validity of the phosphorus index as a means of determining the suitability of the soil for adding or not adding more phosphorus to it. Related to that question, for Dr. Brahana, is do you think that you could use phosphorus as a dye type of trace medium? And let's see physically how phosphorus itself moves. I understand that there are maybe 3 different phases of phosphorus that may be involved. One is fully soluble, one is partially soluble, and another is basically sort of insoluble or a silty type of material. I think these may behave somewhat differently than the than the dye tracings that you are using. And so I'm wondering if you have something in mind to duplicate with phosphorus of the type that might be appearing in the manure, some of the tracing effort. Thank you.
Thanks for the question. Andrew Sharpley, who is has handled that, is a very knowledgeable, he is probably one of the top scientists in the United States. Phosphorus itself, I've worked on multiple projects with him, and we maintain our friendship even though it's a us versus them. Now, the phosphorus itself that is being spread on the fields, most of that is in a form that tends to get sorbed or attached to clay particles. And when we have storms, floods, these get washed, they get washed into the creek, and then from there they become, the soluble form is what creates some of the algal blooms and other problems. Phosphorus is a difficult tracer to work with, so I'm not aware of anyone else who has used it per se as a tracer. I did not have plans. It requires some fairly sophisticated analysis, and we're getting some of those analyses from Dr. Nix down in Arkadelphia, but in answer to your question, no, that's not in the plan for now.
All right, thank you. The phosphorus that issue, I've asked Dr. Sharpley about this in pretty much the same sort of way. And basically, he has no knowledge of an ability to account for the phosphorus. He measures it in the top 4 inches of soil. He has no idea whether it's absorbed by the fescue roots down to 18 inches or whether it keeps going. And since this process is based on a phosphorus index, and they don't really know where the phosphorus is going, it's pretty preposterous to use a phosphorus index as the foundation for the non-point discharge elimination system when it comes to manure. That's my comment. Thank you.
Thank you.
Hi, I'm Margaret Britton from Fayetteville, Arkansas. Couple questions, also some about phosphorus. Is anyone looking at total phosphorus, total nitrogen, and pH in the water, and we're seeing any significant changes there? My other question is on the plasma arc stuff. If that were to work the way they hope it works, what would that actually do?
I don't think Dr. Brahana wants to touch the phosphorus. We are looking at doing much more detailed phosphorus sampling at the Buffalo River. We have done some, but we don't have enough data to really say one thing or another. But I'm looking at trying to get some funding to increase our phosphorus and our metals and our other anions that we might be monitoring. Unfortunately, we've done this project on E. coli on essentially a shoestring, and it's been difficult to just get enough money to do the E. coli sampling. So we're working on trying to get enough money to do additional sampling for other analytes. Maybe in a few months I'll know something more on that.
So, sorry to interrupt here a little bit. We're really kind of running out of time, so if we could keep everything really brief, I would appreciate that.
To my knowledge, and from what we've been able to discover through the FOIA, Freedom of Information Act, it's very little. I think it's going to be, they're proposing a closed-loop system, which in my mind and what we've been able to ascertain is that it will eliminate the waste fields and the ponds temporarily till they can get it up and running, and it's going to be converted into another form of matter. And we haven't been able to really ascertain exactly what that means. The schematic diagrams show that there's a chamber and the feedstock's fed, and then it gets the plasma is electrodes creates an arc. The temperatures can get up as high as 10,000 degrees, and so it's creating another form of matter, an ionization process, and we don't know. We don't know what this means. I would suspect they're just trying to figure out what to do with the waste and convert it into a form of steam, recharge water, and keep a loop going that turns this waste into a completely another form of matter.
What I would suggest to everybody is that once you find that information out, once you have more information, you'll be putting it on the Buffalo River Watershed Alliance webpage.
Yes.
And so that we'll have links and people can go and understand a little bit better about this technology. Okay, we have time, I'm sorry, just for one more question. Sorry about that.
Anna, there are two committees that are going to be involved in looking at the proposed change. This is, and those names are published on the General Assembly website, are they not? As the present construction of those committees?
Yes, they are.
Is there any merit in having folks here and folks everywhere communicating with those representatives and expressing their opinions about the issue?
Most likely there will be. At this point, I think, of course, contact your representatives and encourage them whenever you like. That this, as soon as the meeting's set, then we're going to figure out our strategy as far as look at the committee members, see a lot of times we already know who is in support and who isn't, and then we'll do targeted outreach. That it's not in the past. Representatives have gotten really frustrated on issues with people contacting them if they're not on a committee or if they're already voting for whatever. I mean, I think if you don't know, then definitely call them and ask them what they're gonna, how they're gonna vote on this. That we will definitely be doing outreach as far as who to be contacting once the committee hearing's set and the elections are over. That we'll know.
Okay, sorry about that. That's all. That's kind of all the time we have. Jan, do you want to come up here?
We are going to end this evening with a sing-along. We have a choir that has been practicing this song, but it's a very easy song to the tune of "Oh My Darling Clementine," and we have passed out song sheets, so we're hoping that you will join us. And this will be your first and last rehearsal. If you want to be part of our video, there's information at the bottom about where to meet tomorrow for the filming. And we encourage you, even if you do not sing, to lip sync. You may come to the video and not even sing if you want to. But choir, it is time now to come up and everybody join us. Okay, and someone is making an announcement while we're lining up.
Hi, everybody. I just want to invite you all to a fundraiser that we are having November 15th at the Parthenon Community Center. And it's on the shores of the Little Buffalo River in gratitude for all that we get from the Big Buffalo River. And I invite you all to come. Parthenon is not that far away. It's just right out there. It's about an hour and a half, more or less. And it's November 15th. I have some flyers. I encourage you all to come, tell your friends about it. It's a fundraiser for the Buffalo River Watershed Alliance. Thank you very much.
Just one quick announcement. I canoed the Buffalo yesterday from my home on the Little Buffalo River to Carver. From Hasty to Carver, we smelled hogs. So it's there. Please come out, enjoy your National River while you can. Thank you.
Thank you all for coming tonight. We really appreciate all the support. Thank you all presenters. Those were all excellent, excellent presentations. And I have one last announcement. Someone actually lost their glasses here tonight. If these are yours, please come up and retrieve them.